the hazards and the risks of electricity. I just chosen the word place, be safe. The word be safe is highlighting the hazards and the risk of electricity like burns, electrocution, shock, arc flash or blast, fire and explosions. Just I found on internet and I copy pasted. So just I like it actually, because be safe means easily we can memorize what kind of hazards and risks relevant to electricity could be there. Now, the introduction of electricity, as I told you, even though we are not electrical engineers, but still it's important for us as a safety leader to have some foundational productive informations to work and to support, in shape of safety regulations to the safety team and the electrical systems. An electrical circuit has three parameters. We have voltage or potential difference measured in volts. Voltage we measure in volts. We have current like I or rate of flow we measure in ampere, and we also have resistance to the flow like measured in ohms. So there is a link, strong link, linked together by Ohm's law, like V is equal to I multiply R. If you want to know about the volts, surely you must be familiar what are the amperes or kind of current, or what is the resistance in shape of ohms. If you have two figures, the third automatically you can find out. And vice versa, if you want to know about resistance, then I and volt figures must be with you. If you want to know about I like amperes, then V and R must be familiar for that particular formula. And all three formulas are quite straightforward. V is equal to I multiply R, and I is equal to V over R, and R is equal to V over I. So you want to know about volts, amperes, or current, in other words, or resistance in shape of ohm. These are the formulas you can apply. But yes, the current is given the symbol I, and if you know the values for two of the elements, you can calculate the third automatically. This diagram also I added from my side, like AC alternating current and DC direct current. Like alternating current is kind of main supply in AC, and voltage alternates from plus V to negative, like plus positive to negative and back again. Therefore, current flows backwards and forwards. Like in UK, 230 volts, 50 hertz, or 120 volts in USA, 60 hertz. Like in Saudi Aramco, they previously recommended 110, for electrical power tools. But now with RCD or with GFCI for 110, and RCD residual current device with 220 actually. That is what they recommended. But mostly now they are moving towards 110 in most of the areas. But now several areas I noted still 220, and it's vice versa according to the need. But if your extension boards or your plugs are 110 and you are using an equipment, a power tool, which is gonna require 220, then it's a mismatch actually. So that is why you need to standardize. And I'm sure in Sadara, you would have a clear standard for AC and DC supplies. Now battery, what is DC? The direct current, like battery supply in DC, current flows in one direction only. And look at even in the picture, the diagram. This is alternating current, so zigzag, and direct means direct, no obstruction at all. Now the hazards and risk of electricity could be electric shock, burns, fires, and explosion, arcing or secondary effect. I just added this diagram just to understand, what kind of labels or different kind of symbols we observe and put in place. And we can see them even on the different electrical equipments, including the panels, even on the machine sometimes. Now, electric shock, The most important one and directly relevant to the safety leaders to understand what can happen, what is the effect if the milliamperes flowing through the body, what would be the effect. Of course, terrible effects will be there, but let's see 0.5 to 2 milliampere is kind of a threshold of sensation. 2 to 10 tingling sensation like muscle could also be tremor or painful sensation. If it is 10 to 60 milliampere, muscle contractions, inability to let go, inability to breathe even. So that means breathing issues would also be starting from 10 to 60 milliamperes, and 60 and above, of course, it's more terrible situation. So ventricular fibrillation or cardiac arrest like CPR, extreme muscle contractions, burns and contact point and deep tissues would also be damaged. Several incidents happened. The person just touched the line and he burned out. Actually, the fire was also there. So it depends on the milliamperes or depends on the volume, how much current flow was there. That is uh, that is why we truly need to place different warning signs and let people be familiar to be away from electrical systems. Now, the electric shock, there is a severity of shock, which is influenced by voltage, as I mentioned earlier, the duration, the current path, the resistance, the contact surface area, environmental factors, clothing and footwear, and of course, frequency. Like voltage mean higher the voltage, greater the current. Quite straightforward, logical point. Duration, exposure time, and current path route through the body. Resistance, maybe skin condition, clothing. That means if your skin is, let me mention, if your skin is very much powerful, or your clothing, or you have proper skin care, in shape of wearing certain PPs or the right set of gloves, even skin would be, but still skin condition, the condition means the health level of your skin is also pretty important to ensure. Accordingly, the resistance would be there, because if your skin is weak, the resistance will be very less. If skin is strong, a little bit more resistance, which is required, by the way, to fight back with electricity. Even it's hard to fight back, but if the more you are stronger, the less chances would be, to die, God forbid, or to be expired. Now, clothing is another critical element. Contact surface area, more skin contact, more swearing. Environmental factors, like if metal surfaces are there and humidity also. And clothing and footwear affects resistance and blocks, reduces current flow. And frequency, AC more harmful than DC at same shock trend. And I hope any one of you have understanding what is the abbreviation of FRC. Any one of you, please. What is the abbreviation of FRC? FRC stands for what? Any one of you, please. Because he is talking about
It stands for flame resistance.
sorry.
Load. It stands for flame resistance. Loads.
Okay. So flame or fire resistant clothing, which is of course very much important, especially for our electrical technicians, engineers, whoever. And those are the affected guys, to be very honest, because sometimes we issue the permit and we as a safety, of course, get aside. Now the affected guys who are working around or exactly working on the panels on all that electrical systems would be surely the effect is, if something goes wrong, God forbid. Now, the electrical burns, we have direct electrical burns or indirect electrical burns. Direct electrical burns is a current flowing through the body. Entry and exit points, internal tissues burns. This is direct electrical burn. An indirect electrical burn, an electrical accident causing something to overheat or explode even, like arc flash or arc blast. These are the difference between direct electrical burns and indirect electrical burns. But of course, both are terrible. Now, the electrical fires and explosion, what are the causes? We discussed already, but still, since we can refresh, faulty electrical equipment, overheating, overloaded system, overheating during charging. Equipment may be misused or flammable atmosphere with wrong type of equipment and accidentally created. Electrical equipment producing heat or spark in normal use and poor internal electrical connections. So these are some of the causes of electrical fires and explosions. Now, what is static electricity? If we rub our hands, more faster. So I hope you have some understanding. The heat will produce and some sort of static electricity. If we rub this ball pen and even with our hair, it will produce some sort of energy, and we can pick up the dust particles or small. So it will touch automatically. So that means it's a game of friction. It's a game of hitting something with the metal, something with the surface. Like you have oil storage tank or you have chemical storage tanks. The first few liters you are going to put in place in the tank, they have a chance to produce static electricity because the liquid is directly hitting to the ground. And if you don't have bonding or kind of earthing or even we call it grounding as well, even though in that case to avoid static electricity, bonding is more preferred and logically technically more sound. But what if that is not there? So more chances of fire, more chances of explosion, and several incidents happen. Sometimes bonding is also there, but non-functional. It didn't work actually. So it's a build-up of potential difference like volts between surfaces. Two surfaces rubbing to each other, that would also create electricity, static electricity caused by friction. Surfaces become charged and also static shock. Very short duration, static spark. It's a game of seconds. And spark caused on contact with earth and risk of igniting flammable liquids. Now in Sadara, how do you avoid static electricity or how do you manage static electricity? Any one of you have an idea? Have you studied your procedure relevant to electrical isolations or electrical systems management? How do you manage static electricity in Sadara Masha? Because there is a risk of igniting flammable liquids. And your chemicals, of course, would have some sort of flammability. How do you manage static electricity? Anybody have any idea? Otherwise, this is a great learning opportunity. You can go back and see how Sadara is managing static electricity. Surface to surface, even filling of different drums or different tanks, or storage of your hazardous kind of wasted chemicals or something like that, or you are storing them. And what is your way to avoid static electricity? Or if it is there, how it is being managed, through bonding or through grounding, or what other methods are there? Or you have not at all static electricity anywhere within Sadara. It's a good learning opportunity. Now, arcing is an ability of electricity to jump like across an air gap, usually involves high voltage, overhead power lines. And what are the main hazards? Because of arcing, electric shock could happen, direct burns from the earth, indirect burns from the radiant heat, and also damage to eyes from UV light, ultraviolet light. And we have studied radiation, different kind of Secondary effect, physical injury caused by an electrical incident, falling off a ladder, like causing cuts, bruises, or even broken bones. We also have dangerous activities, especially use of poorly maintained electrical equipment. These are the dangerous activities. Use of electrical equipment in wet environments and work near overhead power lines, and not keeping safe distance, or have sometimes no idea what that safe distance is all about. Contact with underground power cables and work on mains electricity supplies. These are the dangerous activities, and there must be some sort of safe kind of procedures or safe work system, especially the SOP, standard operating procedure, working for these dangerous activities. No, we have fixed and portable electrical equipments. Yes, it depends on the conditions and practice likely to lead to the accident. If that fixed or portable electrical equipment is an unsuitable equipment, using equipment in damp conditions or even misuse would be another reason to create a disaster. So physical abuse or improper repairs, taped up joints like temporary solutions. And these temporary solutions, while constructing my home, like here in Pakistan, uh, not a single joint is there. I directly brought wire from each point directly to the panel, and no joint actually. Whatever wire he needs, I'm ready to invest, and I invested even. I make sure to avoid any sort of joints actually, because the joints, if you use temporary joints and putting tape, or maybe after a few months, especially in summer season, because of heat, because of some kind of environmental aspects, that tape wouldn't be resistible actually. It is not designed for a long period of time. So because of that particular joint area, the chances of short circuit, and short circuit means mostly a reason of fire accidents also. So we try our level best to make sure nothing should go against us, and the best practice is to follow safety regulations. So use of faulty defective equipment must be avoided. Let not your employees to be the hero, that if any necker wire is there, still I can work. If plug is not available, still I can use. Don't let them show their heroism, because safety is not a joke. It's purely something seriously we have to follow and make sure nothing will go wrong, God forbid. Or we can just try to minimize the risk levels or bring them at acceptable level or tolerable. But electricity, even at certain level, is not tolerable actually. So chemical abrasion, damage to the flags, and lack of inspection, testing, or maintenance. Sometimes inspection is there, testing is there, maintenance is there, but not effective, not productive, not in line with the plan, not in line with the guidance, as per international standards or your internal procedures even. Because who is doing it? The human beings. And human beings means, again, human error, plenty of other factors, like you never know. If a gentleman is working with you for 12 hours, as I gave maybe earlier also one example, 12 hours equal to 43,400 seconds. And in which second, which of our employees is careless or overconfident, or maybe ignoring or having some unsafe act, or hiding his core knowledge from us, and just went for this particular dangerous activity or process, the probability will go up, and the more chances of accident for sure. That was all about 11.1.